Alright, howdy. I hope life is good for you. Um, Standard form. Writing the standard form of linear equation given 2 points on a line. So, kind of a pain. If you can figure out a quicker, more elegant method, please let me know. I would like to know. This is kind of, I feel like this is sort of a hack, but oh well. So all right. I'm just giving you 2 points for each line. It might be where you actually start with the graph of the line, um, and you say like you've got a line there, and you pick out a couple points, and then use that information to write the standard form of the line, of the equation that governs this line. Uh, but I'm just giving you 2 points. We'll take it from there. So what I would recommend doing is first kind of go through an intermediary stage of writing the equation in the point slope form and then working from the point slope form up to the standard form. Um, you could also write it as you could write it in slope intercept form and then go from there, but I think that'll require an extra step, so that's why I'm recommending the point slope form. So in the point slope form it just means if you've got I don't want red. Red is kind of scary sometimes. Uh, if you got a point on a line, you call it x1, y1, the coordinates, x1, y1, and you've got the slope, you call it m. Y minus the y coordinate equals the slope times x minus the x coordinate. That's all that's saying. So if you got the slope and you've got a point, then you can easily write the point slope form. That's why I'm recommending this, because we can take these 2 points and figure out the slope. Then we've already got a point. In fact, we have two of them. We only need to use one of them. Then we can write it like that, and then we'll just move stuff around until it looks like this. All right, let's jump into it. So the slope of a line is the change in y. This triangle is a Greek letter, it's delta, and that's just a way of symbolizing change, or difference. I think delta is d for difference, the difference in y over the difference in x, if that helps. Some people call this rise over run. Rise and run don't mean anything to me, so I call it just change in y over change in x. And the way I do this is just stack the 2 points on top of each other, like that. So I'm just moving this one here below this one so it's easy to see. Okay, so I want the change in y over change in x. So these are my y's, these are my x's. So how does y change as it goes from 12 to 3? Well, it decreases by 9. 12 minus 9 is 3. Okay, so that's my change in y. Change in x, I go from 6 to 2. So I go from 6 down to 2. That's a decrease of 4. So my slope would be 9/4. 9/4. Okay, I could use that to write the point slope form. So I've got y minus. Now let's pick this point, 6/12. So y minus the y coordinate of the point is equal to the slope, which we just figured, 9/4, times x minus the x coordinate, which is 6 in this case. Alright, now we can start moving stuff around so it looks more like this, where it's something times x plus something times y equals something, where these somethings are integers and a isn't negative. And that's a style thing. Okay. So the first thing I want to do is just distribute this 9/4, and so I've got. If I just distribute, I should have done something that wasn't such a pain, but oh well. 9/4 x, so 9/4 times x is 9/4 x, minus 9/4 times 6. Let me do that up here. 9/4 times 6 over 1. I could do some reducing first. 2 goes into 2, or into 4 2 times. 2 goes into 6 3 times. So I can cancel out a factor of 2 out of those guys. So I've got 9 times 3 is 27 over 2. So minus 27 halves. And I'm just going to leave it as an improper fraction. There's no reason to make that a mixed number or anything like that now. Definitely not a decimal. Don't do that. So we got y minus 12 is equal to 9/4 x minus 27 halves. So it looks looking kind of weird, but don't panic. So I'm panicking, so I'm gonna draw a line here. Okay, just to kind of help me keep everything straight. Okay, so we want x's and y's on the left side, and then some number on the right side. So let's get this x over on the other side. So to do that, this is positive 9/4. So to move it, we subtract 9/4 x. So I've got, now on the left side, I've got negative 9/4 x. And then I'm going to call this 1y. Just, whoa, 1y. Just so it looks like, you know, something is in front of the y. Negative 9/4 x plus 1y. And actually, let me go ahead and move that 12 while we're at it, just to move it to the other side. So plus 12 plus 12. So I've got minus, so we have this minus 27 halves plus 12. And I'm just going to leave it like that instead of figuring out common denominators or, you know, turning this to a mixed number. I'm just going to leave it like that. That's fine. And you'll see why in a second. Okay, so we're getting close. But we need, so a here is negative 9/4. So that's not good for a couple of reasons. One, it's a fraction, not an integer. Two, it's negative, so we don't like that. So let's deal with that. So if I want to turn this into an integer, it's being divided by 4. This negative 9 is being divided by 4, and so that's what's making it into a fraction. It's being cut up into 4 pieces. So to undo that, I just multiply by 4. And I want to make it a positive number, so a negative times a negative is a positive. So I'm actually going to multiply this by negative 4. Okay, but I'm going to have to do that to both sides of the equation. Everything, both sides of the equation. You can't just pick, you know, a term in an equation and multiply it by something. That kind of changes what the equation is talking about. If you're going to do something, do it to both sides of the equation, and do it to everything on both sides of the equation. Okay, so negative 4 times negative 9/4 x would just be 9x. Negative 4 times 1y would be negative 4y. Okay, negative 4 times negative 27 over 2. I'm going to do that down here. Negative 27 over 2 times negative 4 over 1. Okay, so you can take a factor out. 2 times 1 is 2. 2 times negative 2 is negative 4. So I'm pulling a 2 out of both these, canceling out a 2. So negative 27 times negative 2 is, what is that? Positive 54. Is that right? Yeah. Over 1. So this becomes 54. 54. And then 12 times negative 4 is negative 48. So 54 minus 48 is 6. See how that's easier to deal with? I just left this as a fraction. I left it as just addition instead of trying to add those together as they were, because I knew some stuff was going to go down that dealt with you know, like fractions being elsewhere. So you just be patient. You can let it be what it is for a while, and then it could get easier. I mean, you could do it right away, but it's more of a pain than it's worth. Okay, so there we have it. 9x plus negative 4y equals 6. So let's check this. I've got something times x plus something times y equals something. All these somethings are integers. You know, 9, negative 4, and 6. A is not negative, and so we are good to go. Now, that took a while, and if you can think of a faster way to do that, that would be great. Let people know if there's a kind of a sleeker way to do that. Otherwise, this works. It's not the most elegant way, but it works. So I'm going to let you do these other two. So the process is you're given 2 points. So you can use those 2 points to figure out the slope of the line. So the slope is just change in y over change in x. So you want to just, for me it's easier to visualize and keep track of things if you put the 2 points on top of each other. So change in y over change in x. That'll be your slope. Now, once you have slope and a point on the line, you've got 2, so you just pick one, maybe pick that one. Once you have a point on the line and the slope, you can write a point-slope form of the equation. So y minus the y coordinate of the point equals the slope times x minus the x coordinate. Then rearrange it following the rules of algebra until you get something like this: ax plus by equals c. If the coefficient in front of x is a fraction, and or if it's negative, multiply everything by something so that it's a positive integer or 0. You might, if you don't have an x, you can just call that 0x, if that makes sense. So, all right, good luck, have fun.